Morning again. Today we will be seeing the gaseous state. We know gases matter exist in three states: liquids, solids, and gases. Solids are characterized by definite shape, volume, area, and other properties, whereas liquids have definite volume but no definite shape. And gases have no definite volume and no definite shape. They have the highest compressibility and they have the property of diffusion. So we'll try to see some of the properties of gases and their laws, which you have studied in lower classes. So if you see the physical properties of gases, we have here volume. It is measured in liters, pressure, temperature, number of atoms. That is Avogadro number 6.022 into 10 to the power of 23. So this is the basic law of gases, Boyle's law. And Robert Boyle is called father of modern chemistry. He has proposed this law that pressure and volume are inversely related. If pressure increases, volume decreases, vice versa. Volume is inversely proportional to pressure. PV is equal to constant. And if there are two gases, P1 V1 is equals to P2 V2. This is Boyle's law. You can see here when pressure is less, volume is 1 liter. Increase pressure, volume decreases. That's what we have seen in Boyle's law. See here. 1 atmospheric pressure, we have more volume. 2 atmospheric pressure, somewhat lesser, least volume. So when pressure increases, volume decreases. Next law is Charles' law. It shows the relation between volume and temperature. So volume is directly proportional to temperature. If temperature is more, volume is more because the molecules of gas are more separated. So volume is equal to kT. K is a constant. V1 by T1 is equal to V2 by T2. Here we can see it also, Charles' law. Temperature is 200. Volume is 0.5, less volume. We are heating. Temperature is doubled. Volume is also doubled. You can see here. Temperature is less. Volume is less. Temperature is more. Volume is more. Next, you have another basic law that is called Avogadro's law. Volume is directly proportional to number of moles or number of molecules. If number of moles are more, that means quantity is more. So quantity of a gas is measured in moles. That is Avogadro's law. See here, 1 mole, we have 22.4 liter, that is STP. We add gas, volume is more, volume is doubled, number of moles are doubled. So if Dalton's law, that is another law, that is Gay-Lussac's law, at constant volume, pressure and temperature are directly related. If volume is constant, kept constant, pressure is directly proportional to temperature. If pressure is more, what happens when we press a gas, it gets heated up. Pressure is more, temperature is more. That is Gay-Lussac's law. Total pressure in a container is the sum of pressure of each gas would exert if alone in the container. Suppose there is a mixture of gases, so the total pressure is equal to the sum of the individual gases or partial pressure of the gases. That is Dalton's law. There is another property called vapor pressure. When water evaporates, the vapors are collected over the surface and they exert the pressure, that is called vapor pressure. Now we have a gas equation, PV is equal to nRT based on these three gases. gas laws, Boyle's law, Charles' law, Avogadro's law, and this Dalton's law. All these gases are called, they represent ideal gas, and ideal gas equation is PV is equal to nRT, where P is the pressure and N is the number of moles, R is gas constant, R is the universal gas constant we call. Next, but most of the gases deviate from ideal behavior. Why do they behave? Difference between ideal gas and real gas, you see here. Obey PV is equal to nRT gas equation. Always they obey. Only very low pressure and high temperature. That means at low pressure and high temperature gases are ideal only. Molecular volume is zero, but here small. Molecular attractions, ideal gas zero, but there is some attraction between. Molecular repulsion, for ideal gas it is zero, but there is some repulsion between the molecules of a gas, and hence they take up, they are called real gases. Real molecules do take up space and do interact with each other. So need to add correction factor to ideal gas. So that ideal gas equation has been corrected based on kinetic theory of gases. What is kinetic theory here? So kinetic theory of gases, if you remember, gases consists of a large number of tiny particles called molecules. And these molecules are in random motion. They are not in state of rest. They will be moving. And hence, as they move, they collide with the container and themselves also. As a result, pressure changes. And there are two corrections in the ideal gas equation, pressure correction and volume correction. In the next class, we will see what are pressure correction and what are uh, volume correction, and that becomes van der Waal gas equations. So what we have learned today is gases. Gases is the most random state of matter, and it has some of the basic properties, physical properties, and like volume, pressure, temperature, and number of atoms. The relation between them is called gas laws. We have Boyle's law. We have this volume, when pressure increases, volume decreases. P1 V1 is equals to P2 V2. And there is a relation between volume and temperature, that is called Charles' law. And Gay-Lussac's law means it comes when volume is kept constant, pressure and temperature are directly related. So the gas which is obeying gas laws is called ideal gas. Ideal gas is considered that there is no molecular attraction. But kinetic theory of gases told us that there will be some attraction at high pressure. When pressure is high or temperature is low, molecules come closer. At that time, the gas will not be an ideal gas. There are some corrections, pressure correction and volume correction, and when we correct these two, it becomes a real gas equation. And we have to derive that equation, that is called van der Waal equation of state, and we will derive in the next class. So today you remember this thing. Next class, in the next class, we will be seeing other things.